In the previous video, I have discussed about the electrical resistance and Ohm's law. In this video, I'm going to just talk about electric shock in general. Electrical resistance depends on what kind of electrical resistance the material have. You have a different kind of a current flow, and I guess depends on the voltage drop, but you get to have a different kind of current flow. Human body, human skin, actually varies the resistance quite a bit from being a very dry skin that human skin can be like a 500,000 ohm to if you have a wet skin, like maybe you get sweated and or like if you have a salty water on your skin, then from 500,000 ohms to 100 ohm. So there's a big difference in a resistance. It can be. So imagine, or like when on your tongue, you're going to have a lot of low resistance. So this is 1.5 volts battery. AA battery is like 1.5 volt. You know, in a dry skin, you touch it, you don't feel anything. But what happens if you touch it in your tongue? Same voltage, low resistance, larger current. You're gonna feel it, right? The electric shock, is it having a high voltage is more dangerous or current that is more dangerous? I mentioned that, oh, my son took the balloon that I inflated. Hold on for a second, I'll go and pick up the balloon. So look at this balloon. If I rub it against my hair, I can say that this balloon has about 6,000, well, see, you see my hair is being stuck, electrostatic force. 6,000 volts. This balloon can have a 6,000 volts. And doing this, let's see if I can do it. See my hair being stuck. So 6,000 volt balloon, I'm holding it. Should I be worried? Remember that the Van de Graaff demonstration the professor did. And Van de Graaff can have a 200,000 volts. Should you be worried about it? And then if you step on the ground, 200,000 volts down to the ground, that's difference, voltage difference drop is that much. Should you be worried? See, it's 6,000 volts balloon. But if I'm touching both ends, from my right hands to the left hands, that's same 6,000 volts. If I touch the 6,000 volts, right, and then here, grounded, then voltage drop is 6,000 volts. I'm still touching it. Voltage drop is 6,000 volts. Should I be worried? Current flows from high to low. So unless you have a change in voltage, right? And it's closed circuit, it has to be closed. No, I don't need to worry because it is the current that's more dangerous. I've been making an analogy with water and altitude. So altitude is more like a voltage, right? Imagine that if you have a charge and if it's a positive one, it creates the gradient, and that gradient, which is the mountain, and electric field line is along the slope. So you feel the force that moves along in that direction, radially outward. But then the equipotential, which shows the height, it's like a height of the mountain, is an equipotential that shows the voltage. So whenever you have a gradient, then you have a voltage drop. The higher the altitude, the change in height, change in voltage means that, so analogy to the water in a mountain is that if you have a big drop in height, is that you have a big voltage and current flows. So as the water flows from high to low, right? Then imagine that it's a big drop. But if you have just a tiny water molecules hitting you, so let's imagine you're Niagara Falls, right? But if there's no water, but just a few droplets of water hitting you, should you be worried? No, right? You're outside in the rain. The raindrops vertically comes down. It's traveling such a long distance, big change in height. That's hitting you. You don't need to worry about being your neck broken. But like a Niagara Falls, if you have so many water hitting on you, and if you don't want to dare to go under that Niagara Falls, right? Compared to the water raindrops that comes from the cloud, the drop is not that much, but the amount of water current is so much larger, and that's dangerous. So same thing happens with the electric current. This 6,000 volts, whatever the charge that's moving to make it 6,000 volts, there's not too much charge on it that I don't need to worry about how much current is flowing. But the electric outlets on the wall, that's 120 volts. It's actually alternating current, so it's a little different. But that supplies a lot of current because you need to connect to so many different electronic devices in a house. So the power company supplies a lot of current. That means that it's very, very dangerous. So it is the current that's more dangerous. The power line on outside, that's dangerous. But the bird sits on it. It's because that if the bird sits on it on the same power line like this, then what's the volt? So let's say it's 120 volts on this side, and then what happens on the left leg? It's still the 120 volts. So they both have the same 120 volts. If you have the same voltage, will the current flows? Current doesn't flow. You have to have a change in voltage. So if the bird sits onto another wire, then it's not safe. Or to the ground or to the pole, wooden pole, then it's not safe. But if you have that, even though it's a very, very high voltage, let's say, or even have a high current, if you don't have any change in voltage, there's no current that flows through your body, then you're okay. So the change in voltage that matters, but it is the current that becomes dangerous to you. Okay, so that's the end of this video. I'll see you in the discussion.